Welcome to Bite-Size Data Science. We've covered the data science lifecycle from business understanding to data preparation. We're now at modeling. Why are we modeling our data? Here are a few examples. We've been using the Chicago accident dataset in the last few videos. One obvious modeling application is to find accident hotspots. The city could use that to see if they can make changes to reduce the number of accidents. This could be as simple as adding a stop sign or a traffic signal. There could be something obstructing the view like a tree that needs trimming, or motorists being blinded by light at a specific time of day. Another example, we may want to analyze the behavior of customers that have similarities. This can easily lead to product recommendations. In other cases, we may want to predict customer loyalty by doing churn analysis. We may want to detect spam messages or behavior which can lead to fraud detection. There are so many more possibilities. These are all examples of modeling. They require different approaches and have different requirements. How do we pick the algorithm to use? This depends on the problem. Way back in video 1, I said that machine learning algorithms are largely used to predict, classify, and cluster. This is a good starting point to identify the type of problem we're trying to solve. The second requirement would be to see if we need labeled or pre-scored data to train our model. This means that we selected to use a supervised model creation. Without the labeled data, we're out of luck. How do you find out which algorithm to use? The easiest approach would be to use a tool that tries multiple algorithms and lets you choose the best for that dataset. We'll get back to that later. What I would suggest is to first identify the type of problem you have, classification, prediction, or clustering, keeping in mind that recommendation is related to clustering, and then look at what is provided by popular libraries. Let's take clustering, for example. I talked about k-means in video 6 and video W2. I also used it in video 17, 18, and 32. Then I used the agglomerative clustering and dbScan in video 62. One way to learn about clustering algorithms is to look at the scikit-learn library to see what it offers. It describes 10 clustering algorithms and their characteristics. Just having a high-level understanding of these algorithms will give you an idea of what can be done. We can also look at classification and regression algorithms. In general, these would require labeled data. In scikit-learn, it is a bit less approachable, so I would suggest starting with a subsection on support vector machine, decision tree, and ensemble methods. Another approach is to use tools to help choose the algorithm. Here are two examples. The first one is IBM Watson Studio AutoAI. It figures out the type of algorithm needed for supervised learning and allows you to set how many algorithms should be tried. The end result is that you end up with multiple models and their evaluations, which allows you to select the best one. Another tool, SPSS Modeler, provides an extensive set of algorithms for classification, regression, and more. It also provides two operators, AutoClassifier and AutoNumeric, that will try multiple algorithms for classification and regression and provides the information required to decide on the best model. Note that there is also an AutoCluster operator. I am not saying that you should use those tools, but that you should look for tools to make you more productive, and you should look specifically for features like those mentioned here. There is a lot more to modeling, and we'll talk more about it in the next video. See you next time on Bite-Size Data Science, and don't forget to subscribe.